Okay, examples of each. Yeah, we're still in the chapter 5.1, basics of probability distributions. Okay, how tall is a plant given a new fertilizer? Continuous. Okay, this sometimes you measure how many fleas are on parent stock in a colony. Discrete because all fleas are countable. One fleet, two fleets, three fleets, and that is discrete. You cannot count 2.368321 fleets. It's impossible because we count only a total number, a whole number. Okay, if you have variable and can find a probability associated with the variable, it's called a random variable. Again, let's review the definition again. If you have a variable and can find a probability associated with that variable, it is called a random variable. In many cases, the random variable is what you are measuring, but when it comes to discrete random variable, it is usually what you are counting. So, for example, of how tall is a plant given a new fertilizer? Maybe the new fertilizer is useful, maybe that's useless. Okay, the random variable is the height of the plant given a new fertilizer. For the example of how many fleas are on prairie dogs in a colony, the random variable is the number of fleas on a prairie dog in a colony. Okay, now suppose you put all values of the random variable together with the probability that the random variable would occur. You could then have a distribution like before. Okay, let's check this. Okay, I think this part is a little bit okay, so I will just read those cases. Example 5.1.1, probability distribution. The 2010 US Census found the chance of a household being a certain size. The data is in example 5.1.1, households by age 2013. Okay, the number is here. Size of household 1, 2, 3, 4, 5, 6, 7 or more, and the probability 26.7%, 33.6%, 15.8%, and etc. like this one. And solution, in this case, the random variable is x, and x is the number of people in a household. This is discrete random variable. It's impossible to get. Hi, in your household, in your home, you have 2.597 people in your home. No, only 1, 2, 3, 4. Thus, we can think about that discrete variable. Okay. Thank you, sir. This is a probability distribution. Since you have the x value and the probabilities to go with that, all of the probabilities are between 0 and 1, and the sum of all probability is 1. What does it mean? You list all events over there and divide it by all events. You got a probability, and you add all probability together, they will be 1. It means 100%. 100%. Okay. And here, example 5.1.2, graphing a probability distribution. How to graphing this? Check here. The size of household: 1 person, 2 people, 3, 5, 6, 7, like this one. And the probability here. And we can draw like this. We can draw the picture like this. That is one. Okay, notice the graph is skewed right. Oh, so sorry. No one reminded me. Sorry. Okay. Because of my screen here, I can see that. So I forgot to switch the big screen to project my screen. Okay, and here that's skewed. Why? A house or a household has 1 person, that's number 2. The probability is number 2. One household has 2 people, that is the highest ratio, highest probability. And so the distribution is not a normal distribution. It's skewed to the left. Skewed right. Okay. And here, this mean, the mean can be thought as the expected value. Okay, again, expected value, and this is a specific term to describe the math about later. Maybe when we move to chi-square chapter 11, we will explain the expected value again. When we move to chapter 11, chi-square is also important for us, so I will explain it after the midterm. Okay, let's come back here. For a discrete probability distribution function, the mean or expected value is mu. We call this mu, micro or mu. Mu equals summation x times the probability function, and the variance sigma squared, that's the summation of this one. The standard deviation is take a square root of that one, so that will be okay. Let's move. Example 5.1.3, calculating mean, variance, standard deviation for a discrete probability distribution. Here, one people, 2 person, 1 person, 2 people, 3 people, 4 people, like this one. Probability is here. And calculate here. And now add up all new rows and you will get the answer 2.525. The mu is 2.525, and this means that you expect a household in the US have 2.525 people in a house. Now, of course, you cannot have a person, but what this tells you is about the expected household to have either 2 or 3 people in a household. Okay. Oh, I think this one I will skip this one because this part is personally I think it's not so important. Okay, let's move. And example 5.1.4, calculating the expected value in the Arizona lottery called Pick 3. I don't know that because I used to live the New York State, not Arizona, so I don't know. I don't know the name of the lottery. Okay, a player pays $1 and then pick up a 3-digit number. Okay, 3-digit number. If those 3 digits are picked in that specific order, that person wins $500. Pay $1. If the person wins the prize, that would be $500. What is the expected value in this game? Again, what does it mean? Here. Okay. The right order, because the order, for example, the number, assume the winning number is 387. In the same order, specific order. If you got 873, no, they will not win the prize. Specific to the order 387. Okay, let's check the probability. The order 1/10 times 1/10 times 1/10, that would be 1000, 0.01. And the probability of lose, not winning, is about 1 minus 1 over 1000. That would be 0.999. That is the probability of losing. Okay. Then putting this information in a table will help to calculate expected value. Here, okay, win or lose. Okay, win 499, lose minus $1, probability 0.01, probability 0.999. Then the price times the probability, that will be 0.499. This one minus 0.999. Okay. Now add the two values together, you will have the expected value. That will be minus $0.5. It means even you win the prize, but in the long term, in the long run, you will expect to lose $0.5. Since that expected value is not zero, then the game is not fair. It's not fair. Sure, they need to operate the lottery. They need to pay many costs about that. And since you lost money, Arizona makes money, which is why they have the lottery. Is it okay? Sure. This part is a little bit boring, so I will not spend time that you practice. Okay. I think okay. I will skip this part. Let's skip this part. And about the homework, take a look at that. Okay, let's move to the chapter 4.5.